All right, now that we know how to test a claim about a proportion, we're going to adapt that to test claims about means and see if we can tell if people are lying to us when they say something about a mean. And fortunately, the tools and the language are all very similar, so this will be an easy jump from 8.3 to 8.4. Okay, so let's get a claim. Actually, sorry, let me put this chart back up first. I just wanted to say that we are now in 8.3 we did claims hypothesis testing about proportions. So we are on now to doing, oops, let's get the pen working. Now we're on to doing hypothesis tests about means, and then in 8.5 we'll do hypothesis tests about standard deviations. But okay, so let me start with some sort of claim about a mean. So I had this hypothesis, this claim, that Skagit Valley College students on average were leaving their house less than 5 times a week during this lockdown. So there's my claim. SVC students leave home less than 5 times per week on average. And if we want to, we're already capable of writing down the null and alternative hypotheses. So let's just say less than 5 on average. So that's saying the average, and that's this symbol for a population mean. The average is less than 5. Of course, the opposite claim would be that the average is greater than or equal to 5. We still can figure out which one's the null because it has the equal sign in it. So that would be this statement right here is the null, which leaves this one to be the alternative. And this is the point where you would have to go gather some data. You'd have to go ask some SVC students how many times they leave home per week on average during the lockdown. And it just so happens that I gave you a survey earlier in the quarter that asked exactly that. Since the stay-at-home order began, how many times did you leave the house on a typical week? Some of the data is here. This is not the full list. But more importantly for us, we need the sample size, which was 31. We need the mean of all these numbers, which is 3.9, and we need the standard deviation, which was 5.9. So one of two things will happen on the homework. Either they'll just give you these 3 numbers, sample size, mean, and standard deviation, which is fine, very nice. Occasionally they'll give you just the list of numbers. And you will then have to type the numbers into StatDisk yourself and figure out the sample size and the mean and the standard deviation. Most of the time they give you the summary statistics though. So let's work with those here. Okay, so we do have the sample size and the mean and the standard deviation. They're written right there. Normally, if I'm doing this in my homework, I'll copy them down out of the book. So it's jot down the fact that the sample size is 31. That the sample mean, symbol for that is x bar. The sample mean is 3.9. And the sample standard deviation is 5.9. Okay, so those are the important bits we'll typically need to jot down when we look at a homework problem. So I think we can go ahead and get rid of that stuff now. And we are ready to head for StatDisk. So let's start over here. Start from the beginning, demonstrate the whole process. So with StatDisk, go under Analysis, go to Hypothesis Testing, and we are doing a mean with just one sample. So go to Mean, one sample. And notice you've got your choice up here. You can either use the summary statistics or you can use data. If you click on Use Data, it will let you type the data in yourself, but we have the summary statistics. Okay, So first of all, the alternative hypothesis. Keep in mind our alternative hypothesis was that the mean, population mean, is less than the claim, less than 5. So population mean is less than the claimed mean of 5. Significance level was not stated, so the default is always that it's 5%. That's what separates usual from unusual. The claimed mean was 5. That's what I was claiming. It was less than. Population standard deviation, if known, we don't know that. The sample size was 31. So remind yourself of these numbers here in case you've forgotten. Sample size was 31. The sample mean was 3.9. And the sample standard deviation was 5.9. And with those 3 things in there, we are ready to evaluate. Before I punch evaluate, though, you know me, I have to draw a picture at least once on this. So again, what's going on here? Ooh, nice, normal curve, Abel. As we're giving the null hypothesis the benefit of the doubt, and we're saying, okay, for the moment, let's pretend that the average really is 5. And then when we take a sample that comes out at 3.9, say, hey, I got a sample down here somewhere. I don't know exactly how far down it is because I don't know the scale of this curve, but 3.9 is less than 5. And I'm wondering, you know, if this drawing is basically to scale, then 3.9 really is not proof that it's lower than 5, right? It's still well within the range of what you'd expect with a 5. But maybe my scale isn't right. Maybe 3.9 is really kind of off the end of the curve over here somewhere, in which case that's proof that 5 really isn't the true value. We need to figure out the p-value here. That will tell us where that 3.9 is on the curve. Okay, let's see, back to stat disk. Oops, that's not stat disk. Back to stat disk. We're ready to punch evaluate. And the important part for us here really is this p-value, which is 0.154. So the p-value, 0.154. That means our sample is not unusual for this curve. So it doesn't really prove that 5 is wrong. Doesn't prove 5 is right either, but there's no proof here that 5 is wrong. So our conclusion about the null hypothesis is that we fail to reject the null. We can't reject the null here. And again, 3.9 is lower than 5. It's just not convincingly lower than 5. It's well within normal random fluctuation if 5 is true. Okay, so we fail to reject the null. Or if you like to say it the other way, don't reject the null. And then we need to write a sentence about what this means. And when we fail to reject the null or don't reject the null, we basically said, hey, there's not evidence here to reject the null. So again, I'll say something along the lines of there's no evidence, or the book sometimes likes to say there is not enough evidence. To prove that the average number of times SVC students leave home is less than 5. Notice the basic structure of this sentence is I went back and I looked at the claim, which was there, or also here, if you want it in words. And I basically said, because I could not reject the null, I can't go with the alternative. And that's what that's what my sentence says, is I can't go with the alternative. So the sentence says, there is not enough evidence to prove. And then basically I just said there's not enough evidence to prove the alternative. There's not enough evidence to prove that the mean, which was the average number of times SVC students leave home, is less than 5. So I couldn't prove it. Couldn't prove the null, so I couldn't say I couldn't prove the alternative. I could not say the null was a lie. Might be, but there's not proof here. Okay, we will look at least one homework problem in the next video, and then you'll be ready for the homework.